Hi everyone, my name is Balazs Demi. I'm the founder and CEO of Berlin-based Herdius, and I'm here in Tokyo for our meetup. Pretty much my background is I started using Bitcoin late 2012, then moved into mining 2013. My interest kind of dropped out, and it was beginning of 2016 when I looked back at the space. Herdius was launched June of last year, and we are building a blockchain agnostic decentralized exchange that solves everything on the private key level. So in a sense, we are more like an identity bridge on the blockchain, where we use something called a distributed virtual wallet network to split up individual keys of a wallet to different nodes so that we can facilitate transactions and exchange through our sidechain. And you know, since what you have in common in all the blockchains is the private key, what we do is also future-proof because when we have Hashgraph or new next-generation blockchains implement, we can still be a bridge that kind of interconnects all the different ecosystems and allows users to hop from one ecosystem or one chain to another in a seamless way. So thank you everyone for coming. I know no one has heard of us, but you all should. We usually do events to spread the word. That's why I'm in Japan and Hong Kong previously. So Herdius started off as a decentralized exchange, but actually we started calling it identity on the blockchain because you will see that what we do is very much different from just having a simple DEX. And you know, so far we started like a usual blockchain meetup starts, where I tell you when I got into Bitcoin, and then I start trashing some projects, and then we get into the issues. But I always try to structure my talks or my presentations that we go over the issues, and you can see why our architecture is needed and what's missing in this space. So just small background on decentralized exchanges and what they do. The simplest of which you have is just an Ethereum smart contract which does a swap. My problem with a simple smart contract is smart contracts are very inefficient at doing a simple token swap. If you think about it, if me and any one of you in the audience agree on doing a swap, we both have to send our tokens into the smart contract. That's 2 transactions, 2 times gas costs, then pay for the gas for the smart contract itself, and then the smart contract does the swap where we have to wait again and pay gas costs. So that you will see that how we solve it and how that's in our architecture. Then you have the protocols, which provide the underlying platform where people can build additional DEXs on top. A lot of times these protocols were thought to be superficial, and they promised shared liquidity or one liquidity among a protocol. But it turns out that it's actually not up to them, but it's actually up to the relayers and how they implement that protocol to manage liquidity. And oftentimes the aspect of having a shared liquidity pool often turns into having different dark pools where all the decentralized exchanges or relayers are fighting for the same small chunk of users. And then there's a lot of issues that came up across from DEXs. The main one is, smart contract inflexibility. As much as I want to coin this term, it wasn't me. But you can see it happening that smart contracts are immutable code by law, which is great, but the backdraws of that is if you build a system that's solely responsible or solely running on a single Ethereum smart contract, it might happen that in 2 years, other projects like Omise or Kyber are so far ahead that in 2 years' time, since the space is moving so fast, it will be really hard for you to pivot to a model which is better structured to do what you're doing. And then the fee problem, which a lot of people don't consider, especially when you run a DEX. A DEX can only compete with a centralized exchange, in my point of view, if it's cheaper, somewhat comparable in speed, as well as much easier to use. But if you lack the underlying liquidity, then you have a big problem. And the problem with fees is the people who make liquidity in big centralized exchanges is the high market makers, or OTC traders or funds. And they have the criteria of them not being incentivized to go to a decentralized exchange. And that's a huge problem that we are trying to solve as well, but it's industry-wide across all DEXs. Then I mentioned the liquidity, that the more and more decentralized exchanges we create, the more we are trying to split up that liquidity that would go to a decentralized exchange versus centralized ones. And I will talk in another side about the decentralization premium, but it's not, a lot of people would pay for a decentralized experience or nature to do token swaps. But when compared to centralized exchanges, a lot of people or newcomers in the scene don't care about decentralization at all. And the order books and the architectures are all over the place. There's not a standard on how us as DEXs can work together to manage liquidity, whatever small liquidity we have between each other, and that's a problem as well. Front running, it's not a mistake that Anna from Gnosis presented this before, because obviously we're very close to each other. And this is a not so much talked about issue, but it should be. Because when you're a node and you're transmitting a transaction onto an order book, the incentives you would naturally earn are really, really small when compared to the easiness of you being able to front run that transaction, that is, hold back that one, put yours in front. Front running would not be a problem if you have a system which that every actor front runs you. That would solve the problem. The really big issue is that it's actually much, much, much easier for a miner to front run your transaction than to even create an arbitrage bot for centralized exchanges currently. And some architectures solve this, but obviously then you have a drawback of not having an order book or a price discovery. And then you have the problem of ZK snarks not being able to be used in decentralized exchanges. So you cannot, it's really hard to route a transaction in a decentralized way across nodes, so that the nodes transmitting your information order book cannot see the contents of the order. And that's something we're working on. It's pending on peer review or smart people to look at it, but that's an issue we need to tackle as a whole. Then the viability of DEXs, I always say, having just a decentralized exchange is not enough. We also see it with Binance or the big guys now starting to create their own decentralized exchange. And that makes sense. Obviously, that's huge improvement for themselves from transparency reasons. And the decentralization premium, and we are kind of moving in a direction where, for all the newcomers that are pouring into the scene, the fact of something being decentralized and distributed is starting to matter less and less. So we are seeing that shift, I think, happen. So now to basically go into what is Herdius. Herdius is basically, the main use case of Herdius is a decentralized exchange that's blockchain agnostic. Why we are blockchain agnostic is we solve everything on the private key level. And basically, we are more like a chain connector, identity bridge between all the different blockchains. It's just that the decentralized exchange use case is the primary one and the most obvious one to put on this platform. We use something called the distributed virtual wallet network. Essentially, we slice up the private keys of each individual wallet and spread it up across the different nodes, so that we create this system of putting wallets online to manage transactions or trade orders in a side chain. Then we do this, we call it blob, or blocks on blocks. It's similar to sharding, where you shard the state. We create a vertically stretchable blockchain structure that can basically scale itself or stretch itself as demand is rising in our network. So that's shortly on Herdius. Now, the core, as I mentioned, is this distributed virtual wallet network. Essentially, when a user creates a wallet, there's obviously a private key created for the wallet on the main chain, but this is hidden from the user. It's generated in a distributed way. All the user sees when they create a wallet is something that they can sign transactions with, but that's not the actual private key of the wallet. Then this wallet, or this private key, is encrypted and sliced up into different parts, which are then spread across the different nodes in the network. And what happens is, when there's a transaction leaving the Herdius chain, that's when this private key gets reassembled and the funds are moved back on the main chain. So a simple example would be on the next slide, where we have Alice, Bob, and Charlie deposit 10 Bitcoin into their Herdius wallet. Now, when one of them sends a transaction to a Herdius user, nothing moves on the main chain or the main wallet. It's rather kept track of inside the Herdius chain. Now, if Charlie were to move funds out of the network, as you see down there, to Alice, that's when or Bob is moving funds out of the network to Charlie, that's when Alice's private key gets reassembled and the funds are moved. So essentially, you can have the case of having 100 Bitcoins on a Bitcoin network, having 10,000 owners inside the Herdius chain. And when you trigger a transaction out of the Herdius system, that's when you are pretty much triggering the reassembly process of that private key on Bitcoin and moving the funds. So that's why we are pretty much blockchain agnostic, and we don't need any kind of communication channel, bridges, or any kind of similar stuff set up to interconnect the different chains, because at the end of the day, we preserve the native key format of whatever that key is. And that's why you might have seen that we are kind of future-proof, because you can expect that in the future as well, any kind of blockchain, if it's Hashgraph or if it's something better, will still depend on public key cryptography. And we're trying to be more, the way I see Herdius is more a middleware layer infrastructure level, which will enable anyone to hop from one ecosystem to another seamlessly. So if I have Litecoin and I want to use an app on Lisk or Ethereum, I could just buy the token on the decentralized exchange and just send that token inside the Herdius system to that particular app. One really interesting aspect that comes into play is the privacy preserving part of our chain. Unlike other, encryption heavy projects where you basically use a lot of private keys in the ring signature keys or ring signature system, or you have pretty much really heavy encryption to obfuscate someone's identity. In the Herdius chain, what happens is you have more like a collection of masks or identities which you can use. Here was the simple example of Alice sending 5 Bitcoin to Bob in the Herdius system. And now when Bob wants to send those funds out of the network to Charlie, Bob's identity is never revealed, because from the outside, from the Bitcoin network, you're looking at Alice's wallet moving the funds. So in a sense, the identity of Bob is never revealed to someone looking at the Bitcoin blockchain, and it's getting obfuscated inside the Herdius system. So that's a nice little touch of managing identities and using the virtual wallet network. So it's talking about being more than a DEX, and interconnecting all the layers. So not trying to compete with anyone. It's rather that we try to help all the ecosystems that are fighting for small developer communities to kind of enable cross-chain hopping or connecting different ecosystems, so that in the future any kind of token you have in your wallet would allow you to any prediction market or any kind of service, be it running on Ethereum, Lisk Nano, in a seamless way. And that's essentially what we're trying to do. As far as the DEX goes, the interesting aspect of solving everything on the private key or the wallet level is, if a centralized exchange uses our wallet system for their hot wallets, they can obviously match orders seamlessly with our order book, just like any other Herdius user would. And in the beginning, for all the transactions, we would subsidize them, because there's a previous comment on another side that you cannot. Any decentralized exchange will say we will work with centralized exchanges for liquidity. Problem is, they will probably not work with us as much as we want to. I don't think you can expect centralized exchange to take a fee cut in order to work with your decentralized exchange, because you need them more than they need you. And this is the reason why we would subsidize those transactions and make it as simple as possible for anyone to hook into our system to provide liquidity. And the Herdius combination with a stablecoin is really, really interesting, because having this identity bridge system would introduce something I call the really fair ICO or decentralized app. Essentially, you can eliminate the need for tokens. Imagine there's a small dev community maintaining whatever decentralized app or ecosystem. That would require you to buy a token and they would change and then send it to their address. Imagine the case of you sending them a stable coin, or you sending them Ether or whatever you're sending. That instantly gets converted to a stable coin, gets sent to them, to the developer community or that ecosystem. I guess they would have a rule sliced up, hey, this is what goes to the open source devs, this is how much goes to our validators, and this is how much goes to the miners. And then that instantly gets burned. So essentially you're creating ecosystems where apps where you can use any kind of service with whatever currency you have, at the same time eliminating the need for tokens, and you only pay the price for a service that's needed. Now to brief in, we also have a token in there that it's pretty much used as staking currency or collateral. So a simple example is I send someone 10 bitcoins, then we require at least 3 validators to come in and put down the equivalent number of Herdius tokens to do the validation, and all the fees earned from that go to them. We also have, we have a dynamic minting mechanism that allows us to create new Herdius tokens in the case that either the system doesn't function right, or in the case that we have bad actors. And that's why we say we are inflation resistant. A bad actor in our system would be someone who does not lock up stake, meaning that they hold back the functioning of our network. What they could do instead is delegate their stake, meaning they lock their funds in, just like in the Gnosis model, and they basically lend their stake out to the miners who provide the computational power. But in the case of a big holder, having a large percentage of the Herdius token supply, which prevents the network from working right, we would basically reward all the good actors with newly minted tokens, while the bad actors who don't have their funds locked up would get inflated. So thereby, obviously, you're creating inflation in your system, but at the same time, you're rewarding people who already have your token proportionate to how much they hold. Yeah, pretty much that's it. On the governance side, I always say governance is a complex topic to touch, so I always leave it up to the people who are working on it, because I don't think it's going to be something we'll crack in the future. Obviously, that's the end goal of the whole thing, to facilitate network governance. One interesting aspect we do is our order book is maintained by our master nodes, who hold at least 0.2% of the total Herdius stake. And if you think about a decentralized exchange, where is the place where you can kill something from being traded? And it's at the order book. So if the order book facilitates governance, basically which token is listed, which token is not, then that's one use case we're exploring. So that's the end. Follow along, and happy to talk or take any questions. Thank you.
Can I ask one question? That might be a little bit bigger question. So actually, I'm very ashamed to ask this. So what kind of so your project is like to protect the private keys, to use the private keys in a decentralized way, right?
Yeah.
So what kind of threat the private key is, confronting? So what it means, what kind of dangerous factor is chasing on this private key? How this private key can be used in a bad way?
Yeah. So pretty much this is the worst case failure scenario of what can happen inside the Herdius chain. And that's why we want to be sensible with our approach, so that at the end of the year we have our first version running on the mainnet, where the goal is to have Ethereum, so any kind of Ethereum asset and Bitcoin. We would take snapshots in the beginning similar to IOTA, so that if things go really bad, then we can restore restore things to their original state. Now, the worst thing that can happen is a private key for a certain wallet gets lost, and then the initial funds that were deposited to that address get lost. Which sounds bad, but what we do is each individual key part that you saw spread across the different nodes is actually backed up by additional nodes in the network. Because essentially a Bitcoin private key, for example, is 32 bits. If you split that, let's say, into 8 different parts, so 4 bits per piece, and you add the encryption overhead, because we use a mixed network in there to obviously encrypt those private keys, so that one node only knows who else has a key but doesn't know the collective of all the different nodes in the network. Then you basically have the case of, IoT devices. I know it's a buzzword, but at the same time, storing thousands of different keys would take up probably 10 megabytes of data for you to store, and the only thing that those nodes who host the private key need to provide is that they always are up and they provide minimal bandwidth. So as long as you're a node who hosts 1,000 keys and is always there when there's a call to do the reassembly, then that's how we pretty much incentivize them. And the worst case failure scenario that we kind of also mitigate is we use a threshold signature scheme, so that even from these 10 nodes, or 8 nodes, only 70% need to be put together to do the final sending. But yes, the worst case would be the initial deposit being lost.
Okay, thank you very much.